Hello, welcome. Thanks for joining us today. I'm Christi, editor of Spudman. Today's webinar, Making the Most of Secondary Macronutrients, Increasing Availability for Improved Potato Yield and Quality, is brought to you by ICL. This webinar will focus on how in more specialized crops like potatoes, quality is a factor of equal or greater importance to total yield, and secondary macronutrients play a central role in optimizing production. Today's guests are Rob Schaefer, the owner and founder of Mid-Michigan Agronomy, Dr. Jason Haegele, North American Agronomy Lead at ICL, and Christi Falen, ICL's Agronomy Technical Service Manager. Attendees are eligible for one CEU at the end of the webinar, and we will have a QR code up for you to scan. If you have any questions throughout the webinar, feel free to ask them. There's a Q&A section at the bottom of your window, and we'll try to make time to answer as many as we can. So with that, I want to welcome our guests, and we'll start with Dr. Jason Haegele.
Hey, good afternoon, everybody. My name is Jason Haegele, and I welcome you to our webinar this afternoon. We're going to move into the agenda here in the next slide, but really the purpose of this webinar is to start to think about some of the agronomic challenges and successes of this year, and start to think about things that we can do next year to improve potato production and fertility, and specifically we want to focus on secondary macronutrient availability. If you want to go on to the next slide, Crystal. As we look at our agenda, we're going to start out talking about the role of secondary macronutrients and really the impact or the importance that they have on potato yield and quality. Certainly secondary macronutrients like calcium, sulfur, and magnesium being the other two are not new to potato producers, but we want to use this opportunity to review the importance of these nutrients to potato yield and quality, because oftentimes with other crops like corn and soybeans, these secondary macronutrients are not quite as important, depending on the part of the country. We'll talk a little bit about various secondary macronutrient sources, primarily focusing on the dry sources for these nutrients. Common ones like gypsum, potassium, magnesium sulfate, being a couple of examples. But we also want to introduce you to polyhalite or polysulphate, as the product is referred to as with ICL's product portfolio, and talk about where polyhalite comes from, what it is, and some of the unique agronomic characteristics of polysulphate. And doing that, we'll also talk about our North American trials specific to potatoes over the last few years, and highlight some of the key findings that we've learned from those trials. Not only the impact on potato yield, but also some of the impact on potato quality. And then finally, we'll wrap up with an overview of some of the application recommendations for polysulphate, our thoughts around the economics of using polysulphate, and then also the other tangible benefits like a good supply and its positive environmental impact. And then finally, we'll leave some time at the end for question and answer. So with that, I'm going to invite Rob and Christi, a couple of potato experts, Christi being based in Idaho and Rob being based in Michigan, to talk about the role of secondary macronutrients in potato yield and quality, specifically, calcium, sulfur, and magnesium. And we'll also, highlight potassium as well, due to potassium being a component of polysulphate, which we'll discuss in greater detail later. So with that, Christi and Rob, fill us in on the role of secondary macronutrients and their importance for potato production.
Carolyn, let's go to the next one. There we go. All right, so if we want to look at the balance of what we want to do overall, we know that when we're doing nutrition for all of our crops, we have to keep them in balance, as you see in the diagram here on the left-hand side. And we'll go through that a little bit more, but let's start with the magnesium. We know that we have to have the magnesium because it's the central component in the chlorophyll molecule with those 4 nitrogens that are around it. So super critical for us being able to photosynthesize and have good plant growth. And it's also involved in the activation of lots of different enzyme systems. And if you look here on the diagram on the left-hand side, you can see that there's a dotted or a kind of a black dotted line and an arrow that goes across between magnesium and phosphorus. So magnesium is critical for being able to help with that mobility and the uptake of the phosphorus as well. In addition to that, you have relationships and antagonism that can come into play either way, for going with calcium and magnesium, and also with potassium and magnesium. So the interconnections and keeping them in balance are definitely important on that front. Then we also look at the sulfur component, and we know that it's vital for the amino acid formulation and the production of proteins. It's also critical in the photosynthesis process. We know that we need to have the nitrate reductase process and the nitrate going to the amino acids during that time. Also critical for carbohydrate production. So that's really important on the tuber production side. And I'll let Rob talk about the potassium and calcium.
Okay, thanks, Christi. Thanks to ICL for asking me to talk today too. It's quite an honor, so I appreciate it. Now, I'll talk about potassium, calcium. They're probably my most favorite nutrients, potassium being the one that's focused mostly on quality and storability. Tuber quality, as we all know, is big for us. If we don't have tuber quality through storage, we can't sell late in the fall time, late into the spring. It's potassium is essential for sugar and starch formation. It also increases plant vigor and resistance to diseases and low temperatures. Now, potassium in itself, it's something that we actually have been increasing the amount of potassium during the growing season. So we'll apply it in the spring. We'll actually apply it just after flowering to get a little kick on our storage crop. Calcium is one that we've been focusing on mostly in the last year or so. And that's where polysulphate really has helped to increase calcium. The calcium itself in a stressful environment, which has to do with heat and excessive water, excessive rain, really, and more importantly, calcium, when taken up through the root system, it moves up and displaces auxin. Auxin helps us to regrow roots after these stress events. Now, since we know that potatoes are the weakest root system in the world, we need all the help we can get. Now, that's why we're asking polysulphate and calcium in particular to help us regrow roots after a stressful event. Next slide, please. Role of calcium and potassium. You know, when we look at deficiency of potassium in the tuber, it helps us to minimize bruising. Now, bruising, if a potato is heavy or if we're throwing it around too much, excess potassium good potassium levels will help us minimize bruising in potatoes for our storage. Lack of K also results in poor root growth, and let me move this to the side. Excess K can also reduce specific gravity. Now, gravity in the warmer climates like Carolinas, Florida, Missouri, specific gravity matters a lot to us in those stressful environments because we're harvesting our crop early, and we want nothing more than just keep our gravities as high as we can so we can actually sell our potatoes. Adequate K, which depends on your different varieties. We play with K in each variety separately. So some varieties we're more K units than we are actual nitrogen units. So applying K in the spring when we're planting and at hilling and then later after flowering helps us to keep our K levels adequate. And Jason has a slide later in this presentation that is going to talk about when our plants are actually asking us to have these nutrients in place. And those type of slides really help us as consultants and as growers to make sure that we give our plants adequate levels at those timings. Calcium helps us with internal browning, IBS. Also helps us with hollow heart and tubers. Now, calcium is a piece in the whole hollow heart problem. But if we don't pay attention to it and we only focus on the other issues of hollow heart, it tends to come back and hurt us. So we want to keep our calcium in check. It's also got to do with heat necrosis in crops like or varieties like Atlantic, which struggles with heat necrosis. It'll help us get through some of those issues. The next one on auxins is something I've been focusing on heavily in the warmer climates. Displacing auxin from the canopy down in the root system to create more roots is something that we really focused on with. If you have a 4 to 6 inch rain, or even in the southern states where you get an 8 to 10 inch rain, those major rain events, we need to add some calcium with our nitrogen to help us keep our crop moving forward. For the storage part of America, we use calcium for stronger cell structure and help us keep bruising at a minimum. It does help with specific gravity as well. It helps out with skin set. So skin set on some of the thin skin varieties of chips or the table stock varieties, it'll help us get a stronger skin set as well. And then it helps us with improved storability. And then I'll pass it on to Christi.
I'm gonna go ahead and, if you guys have the poll that's still up that was launched, if you would go ahead and answer those questions if they came up on your screen. And then while they're doing that, you can go to the next slide, Carolyn. Okay, so I'll go ahead and cover this, and then hopefully our poll question responses will be up. So we have, when you start looking at sulfur, we know again that we have to have it for having that photosynthesis that's going on. If we have a chlorotic leaf that happens when we have the deficiency with sulfur, then obviously we're not going to have the good tuber production. We're not going to have healthy plants, so then it's going to be more susceptible to pathogens. We have to have it in order to have that high nitrogen efficiency. If we don't have a good nitrogen to sulfur ratio, then we're not going to have good photosynthesis. So then we don't have good tuber yield that comes into play. Also, the other thing that happens is there is one of the studies that I looked at from Oregon State University. They were looking at the uptake that happens when you look at the nitrogen to sulfur ratio. And the actual uptake in the plants for russet Burbank potatoes that are 500 sac yield potential, you had over a 6-to-1 nitrogen to sulfur ratio that was coming when those tubers were pulled out of the plants and what was actually taken up. So we know that we need to have even more than that in the plant and in the soil so that we can be able to have that good nitrogen to sulfur ratio. So if we can shoot for maybe more of a 10-to-1 nitrogen to sulfur ratio within the tissue for the tubers or for the potato plants and the petioles, then we know that we'll be able to have a good ratio that will come when we get that higher tuber yield and we get that good efficiency that's going to happen. As I mentioned in the beginning, the magnesium is critical, and it is that central part of the chlorophyll molecule with the nitrogen around it. So it has to be there in order for us to photosynthesize, to not have the issues that come up. Hang on, we'll do this poll real quick. So out of the secondary macronutrients, which is the most limiting for you, calcium came out at the top, with potassium next, and then sulfur, and then magnesium as far as the secondary macronutrients that were deficient. So thank you for that. So we have calcium and potassium were our top ones, along with sulfur. So magnesium, that's a good thing if you don't have magnesium deficiency, because if we don't have enough, we're not going to partition the carbohydrates from the shoots to the roots and the tubers. And of course, when we're after potato production, we've got to have those carbohydrates moving to the roots and the tubers. If we don't have good nutrient and water uptake and good root structure that's there, then we're going to have less yield. And then we're also going to have a lower specific gravity, like Rob was mentioning. And we know that we need to have that higher specific gravity so that we can have good processing quality that comes from those potatoes. So those are some of the baselines of why we would want to make sure that we have those nutrients in place. Sandy soils that have a low CEC are going to have more potential for magnesium deficiency. Okay, let's go to the next one. Okay, Jason.
Well, thanks for that overview, Christi and Rob. We're going to touch briefly on different sources for secondary macronutrients, and many of these will be familiar to you. Again, we focus primarily on the dry, granular products. Certainly, there are other sources that could be considered, liquids like calcium thiosulfate or ammonium thiosulfate, other types of foliar calcium products. But we have compared here gypsum or calcium sulfate, calcium ammonium nitrate, potassium sulfate, potassium magnesium sulfate, which many of you will recognize that product as Kmag, ammonium sulfate, and then finally polyhalite or the polysulphate that we'll talk about in more detail here in a moment. These are all great sources of certain secondary macronutrients, and the point of this is not to say that one source is better than another. Certainly all of these have various fits in potato production programs or fertility programs for other crops as well. But the takeaway from this is that most of these fertilizer sources only supply one or two secondary macronutrients. And then as we move into potassium magnesium sulfate, we certainly have sulfur and magnesium, and then finally with polysulphate, we have all three secondary macronutrients present in the same fertilizer product: sulfur, calcium, and magnesium. So let's talk a little bit more about mineral polyhalite, or polysulphate, as we like to call it here in ICL. And if we go on to the next slide, we'll talk a little bit more about polysulphate and where it actually comes from and what it is. So polysulphate, or the mineral polyhalite, is a naturally occurring mineral and is mined exclusively by ICL and distributed to farmers worldwide as the product polysulphate. Next slide, please. This nutrient source, this mineral, contains actually four nutrients. So the secondary macronutrients: sulfur, magnesium, and calcium, and then it also contains potassium. As the name of polysulphate would indicate, poly, many, sulfate, sulfur. There are many different sources of sulfur within this naturally occurring mineral. And so we talk about potassium sulfate, magnesium sulfate, and calcium sulfate. But I think it's important to note that this is a complex mineral structure, and it's not a blend of potassium sulfate, magnesium sulfate, and calcium sulfate, but instead it's a mineral that contains potassium, magnesium, and calcium in that crystal lattice, and they're all associated with sulfur in the sulfate form. The other thing I want to point out here that is important for potatoes and other chloride-sensitive crops is that polysulphate is a low chloride source of potassium. Contains approximately 2.4% chloride. And to put this in perspective, potassium chloride or potash or MOP, all names to the same fertilizer source, typically contains somewhere between 45 and 47% chloride. So compare potash, potassium chloride to polysulphate. Polysulphate has substantially less chloride in the fertilizer source or product. Next slide, please.
Did we have the results, Jason, of the poll real quick?
Great. Thanks for that, everybody. So where does polysulphate come from? It actually occurs several places in the world, but from an ICL perspective, the mine is in England. It's on the northeast coast of England along the North Sea at a place called Bolby, England. The mineral is found deep underground and actually underneath the North Sea. So this mine is anywhere between 3,600 feet and 4,600 feet underground. The elevator ride to get down to the mine is about a 7-minute trip, and then the mine shafts go out for several miles underneath the North Sea. The mineral, the polyhalite mineral, is mined. It's brought up to the surface, crushed and screened, and then shipped and distributed worldwide. And so the process is not simple, but compared to manufacturing of other fertilizer products, is relatively simple. There are no chemical processes involved, which not only reduce the cost of the product, but also reduces the environmental impact compared to say nitrogen sources of fertilizers that are chemically synthesized using the Haber-Bosch process. Next slide, please. So the main reason that we're really excited about polysulphate as a fertilizer source for potatoes and other crops is its characteristics or its release profile over the course of the season for sulfur as well as the other nutrients. In this slide, we're first going to focus on sulfur. So that graph in the top right shows the sulfur release curves from several different sources, and also compares it to the uptake pattern for a soybean crop as a representative annual crop species. So that curve, kind of towards the left of the graph, it's labeled 1 is the sulfate release from ammonium sulfate or potassium sulfate. And so the key takeaway from this is that ammonium sulfate or potassium sulfate, these are very readily available sources of sulfur. If you apply these to the soil and you've got adequate moisture, that sulfur, that sulfate will be quickly released from the fertilizer granule and available to the crop. That's a two-edged sword because depending on the rainfall pattern of the soil type, that sulfate can also be lost through leaching if we have very coarse, sandy soil or we have a high amount of rainfall. Kind of the opposite of the spectrum, if you look at that line labeled 4 down towards the bottom of the graph, that's the sulfur or sulfate release from calcium sulfate or gypsum. Gypsum's a great sulfur source if you want a long gradual release of sulfur, but if you need a quick burst of sulfur up front, it may not be the best option. And then as we look at the yellow curve labeled number 2, that's the sulfate release from polysulphate. So kind of intermediate between gypsum and ammonium sulfate, providing a season-long sustained or gradual release of sulfur that coincides with the uptake pattern of sulfur for most annual crops, soybean as an example in this particular graph. The other data that we have on this slide down at the bottom looks at the release of calcium between polysulphate and gypsum. A couple things to point out here is that gypsum certainly has a higher analysis of calcium compared to polysulphate. And the other thing I want to point out here is that the application rates that we're comparing are substantially different as well. With gypsum, this was applied at 2,000 pounds per acre, approximately 460 pounds of calcium per acre. And then with polysulphate, we're looking at 750 pounds of product per acre, supplying approximately 90 pounds of calcium per acre. Even though we're supplying far less calcium with polysulphate, due to the release pattern of polysulphate, we're releasing that calcium, much quicker compared to gypsum, and actually getting a larger amount of calcium released in the same time span compared to gypsum. Next slide, please. So this is just another study that kind of drives home this idea of polysulphate being a season-long gradual release of nutrition. Again, this is specifically focused on sulfur. This was done at the University of Nottingham in England. As we look at this graph, we've got ammonium sulfate, we've got potassium sulfate, again, very quickly available forms of sulfur. Kieserite, so that's the green curve. Kieserite's a fancy term, scientific term for magnesium sulfate. So a little bit slower release compared to ammonium sulfate or potassium sulfate. And then as we look at the yellow curve or polysulphate, we're getting some availability of sulfur early on, but then it continues out much further over the course of the time span investigated in this particular lab study or soil column study. Next slide, please. Some of the other things that we're very excited about for polysulphate is that even though this is a mineral, it's relatively low salt index, especially compared to other fertilizer sources. So as we look at this graph on the bottom left, we have MOP or potash, very high salt index. NOP, that would be potassium nitrate, magnesium sulfate, SOP, or potassium sulfate. And I think, SOP is widely recognized as a lower salt index or safer source of potassium, especially for specialty crops. And then the yellow bar being polysulphate, or the lowest salt index of these 5 products have been compared in this particular study or assessment. Next slide. And then finally, this also ties back to the idea of polysulphate being a gradual or sustained release of nutrition. Now looking at recovery of applied potassium. Now in heavier soils, higher clay, higher CEC soil, usually potassium loss from the soil or leaching is of little concern. But as we get into those coarser soil types, those sandy soil types that may be more common or prevalent in potato production or production of other root crops, potassium leaching can in fact be a bigger issue. And basically the take home from this particular graph is that when we use polysulphate compared to potassium chloride or potassium sulfate, we're getting more in the plant, we're getting more left in the soil because we're still releasing that potassium over the course of the season, and we're getting less leaching through the use of polysulphate because of its gradual sustained release characteristics. Next slide. So with that, let's come back to potatoes. I'll invite Christi to jump back in here and talk about the uptake patterns of a few selected nutrients for potato tubers as well as the potato plant, and really the implication these uptake curves have for fertilizer source selection and really ensuring that we have nutrients available at the right time throughout the growing season.
Yeah, thanks, Jason. Yeah, I guess when you look at those uptake curves and the response as far as where they were at in the days that Jason was showing you with the polysulphate, you look at it, and we definitely, if we start here on the right-hand side with the potato plant, and we look at the days after emergence, 0 here being on the left-hand side, 0 to 15, and then you start seeing a peak that starts increasing at 15 to 30 days. The highest point comes at 30 to 45 days, which corresponds nicely with some of the release of the nutrients from the polysulphate. And then you continue on with that, and those peaks being high for your NPK, calcium, and magnesium. And as you go here on that peak at 30 to 45 days, starts coming down some at 45 to 60. And by the time that we get out to 80 to 90 days, then our uptake is definitely gone down in the potato plant. So that's there on the right-hand side. On the left-hand side, you look at it within the tuber, which is a little different, of course, because we don't have that tuber initiation right off the bat. So we actually start at 30 to 45 days. You can see our highest nutrients that we need are nitrogen and potassium. And they continue to go up even higher when they go up to 45 to 60 days. On up to 75, they start to decline after that. So we have that big draw that comes from the tubers where it needs that nitrogen and potassium. But you can see down on the lower portion that it also needs the calcium and it needs the magnesium. So those are definitely a portion of it as well. And they're going to go out by the time that we get to 90 days, we're starting to see a definite drop as far as that goes. So again, a nice combination of that slow release with the polysulphate matching up with both our potato uptake curves and also our tuber uptake curves that we need during the season for matching our nutrient demands. And so then the next thing that we're going to go into is we're going to start into a review of some of our agronomic trials with the polysulphate in North America. So let's go to the next one. And so some of the things that we were able to find in a few years of looking at them across Minnesota and Michigan, North Carolina, and then up into Canada and Manitoba and Prince Edward Island, either from actual data response or from observations that we got from researchers or individuals that were looking at the trials, And the cooperators would be gross income potential with our increased yield across the trials. And so if we have an increase in the dry matter production, then we're increasing our yield potential. We have an increase in the nitrogen use efficiency. And then definitely some benefits on the quality of the tubers with the reduced hollow heart, the good skin quality, better storability, better fry color, and then more of a balance on the sucrose and the glucose content and the fry color that comes along with that when we don't have too much sugar that will come in. So those are some of the highlights of some of the ones that we saw. Let's go to the next one. And we'll hit a few of them individually as far as some key points. And then we'll go into, Jason and Rob and I will go into more details on these individual trials. So in Minnesota, saw an 18.4% increase in the marketable yield. And over the total response, then we saw 11.5% increase. Michigan in 2021, 17.6% increase. Another one of Rob's trials, we saw a huge response in the marketable yield from Snowden's at 77%, as well as the Frito-Lay variety at almost 40% increase. The Manistee for chipping potatoes at 22% increase. And then in Prince Edward Island, when we did it at planting, a 7% marketable yield increase and higher petiole concentrations for the calcium and the magnesium. And then another one that we did the polysulphate at hilling. So an even bigger response when we put the polysulphate at hilling. So 10.9% over the grower standard practice. And then another one in Manitoba, a 4.3% increase and better quality as far as less sugars and a lighter fry color. Let's go to the next one. Okay, Jason.
Thanks for that overview, Christi. And first mention that ICL has conducted trial work on polysulphate in the U.S. and Canada now for several years on many different crops. And potatoes are one of the crops that seem to be the most responsive or the most consistently responsive to polysulphate. And so we're really excited about the opportunity for this fertilizer source polysulphate on potatoes for, again, not only increasing yield but also the quality parameters that are important for potatoes as well. So I'm going to talk about two trials, one from Minnesota and one from Michigan. And really the key takeaway that I want you to learn or take away from these two slides is that nutrient source matters. So we're going to start with this one at the University of Minnesota from 2018. So this is actually one of our earlier trials on polysulphate and potatoes. And this particular trial was set up to compare different potassium-containing fertilizer sources at a standard rate of potassium. So we have MOP or potassium chloride, we have SOP or potassium sulfate, we have K-Mag, and then we have polysulphate. And these were all applied at 200 pounds of K2O per acre. So you think about polysulphate, it's 14% K2O. The actual amount of product would be a large amount of product, be about 1,400 pounds per acre, which is definitely not a recommendation that we would suggest. But what this study shows is that as we move from MOP just containing potassium to SOP containing sulfur, we see an increase in marketable yield. And then as we move into multi-nutrient sources like K-Mag or polysulphate, we continue to see those increases in total yield and marketable yield. The other key takeaway from this is that at roughly 1,400 pounds of product per acre for polysulphate, supply that 200 pounds of K2O per acre, it's a good indication that polysulphate is a very safe product when it's used at these very high application rates for crops that are sensitive to things like chloride, such as potatoes as an example. Next slide, please. So this example at Michigan State University from last year's more recent example was conducted by Dr. Kurt Steinke at Michigan State University. In this particular trial, we were looking at grower standard practice of potash, which we're calling MOP here, combined with gypsum as the calcium and sulfur source. And then compared to that, we had a couple of different rates of polysulphate either at 357 pounds of product per acre or 720 pounds of product per acre. And as we look at those second, third, and fourth bars, the gypsum with MOP or the 2 rates of polysulphate, those were all standardized at 200 pounds of K2O per acre. So in other words, for those 2 polysulphate treatments, we had polysulphate, and then we balanced the remaining potassium requirement with MOP, potassium chloride. So when we compare to the grower standard practice of gypsum plus MOP, at the 357 pound per acre rate of polysulphate, we had a almost 18% increase in yield compared to that grower standard practice. And the other thing that I want to point out here is that the gypsum application rate was 1,000 pounds per acre. Now, if you do the math, comparing that 1,000 pounds of gypsum to 357 pounds of polysulphate, with polysulphate, we were applying almost 190 pounds less, calcium per acre and nearly 120 pounds of sulfur less per acre with polysulphate compared to gypsum. And so, again, that comes back to the idea that nutrient source matters. It's not just about the rate, but it's also about the availability of the nutrients that are within that fertilizer product. And certainly that has a huge impact on yield, quality, and ultimately return on investment to the grower. Next slide, please. So also in Michigan, we've had the opportunity, the privilege to work with Rob for the last couple of years on polysulphate trials. So at this point, I'll invite Rob to talk a little bit about his experiences and some of the things that he's seen over the last year or two with his trials in Michigan and North Carolina as well.
Thanks, Jason. Okay, this is on our North Carolina research farm on potatoes. You can see the 2 varieties are Frito-Lay 1867 and Snowden chip varieties, and they're widely grown through the Midwest and just they're staple varieties for us to do research on. In that area, our pH levels run from 4.6 to 5.4, very low. That's just what's in that area. So polysulphate, I saw one of the questions on there. It's, can you apply it in low pH regions? Yes, that's the answer. We are running very low pHs. We're actually actively trying to raise some of those during the growing season. This is also a multiple cropping system. So right after potatoes come out, soybeans go in. I'd love to follow up on this in the future and see if in those areas that we are applying these products, that the soybean crop right behind the potato crop benefits from the long-term season-long benefit of polysulphate. Okay, to the trials, you can see we're looking for a rate find. Okay, we're at 360 pounds, we're at 720 pounds, and we're taking some stabs in the dark to try to see if we get a benefit. We've obviously seen a benefit. We're happy with that. Snowden's responded very well to polysulphate, even at the higher levels, even at the mid levels, compared to a grower standard. Now in those areas, we're expecting like 350 bags is pretty normal in a trial setting. This is replicated 6 times. In a trial setting, sometimes we can get a little bit better benefit, but we're looking at, are we increasing? And yes is the answer. Gravity was also collected on these trials, and we saw nothing that would drive gravity down, only that it was not significant, but we were focusing heavy on gravity in the Carolinas. Next slide, please. This is our Manistee chipping variety in Marshall, Michigan, also in 2021. A little bit different trial, still replicated 6 times. And in Michigan, what we run is a 4-row plot, 2 rows of a russet and 2 rows of a Manistee side by side, and we're getting data from both, since Michigan is a chip storage state and a fresh crop state. We feel super good that we can get data in both markets, which is important to Michigan itself. So we're looking at US ones, significantly different in both versus the grower standard. and well, I misspoke there. It's significantly different in the US ones compared to the grower standard. And we take these chips, save a 50 tuber sample, bring them back to our storage in DeWitt, Michigan, and chip them out in December, January, and February. We pulled 3 different chipping timings, and each timing the storability was still holding very good with the polysulphate additives. Now, if we look at one of the slides that's going to be coming up, is going to talk about mixing polysulphate with other products. Here we're mixing it with gypsum, a PelGyp, and these polysulphate mixes well with other products. That matters to us in large agriculture because we can't be spreading this product separate from other products all the time. We need to be able to blend it with other fertilizers to get across our fields in a timely manner, and saves us money as well. Next slide, please. So overall, polysulphate at 320 pounds with Magnesium is significantly different and higher in the number 1 tubers. Total yield is also trending upwards over the grower standard. Manistee is a large chipping variety for us in Michigan and only growing. So getting this product into our marketplace is going to be helpful. Russet North Dakota did not show the same benefit, but this is 1 year, 1 location. And guys, in research, we don't hang our hats on that. We go for multiple years and multiple locations. So we're going to keep looking at it like we are this year. And Russet North Dakota, with the addition of calcium and potassium, should benefit long term. This was a virgin soil that we actually put this trial in. So let's give it another year and see where we're at. But 1 year, 1 location, I wouldn't get too worried about lower than the grower standard. So next slide, please. And
Okay.
this is on to Jason.
Thanks, Rob. So we'll briefly move through these, but we've got 2 examples. Now moving from the United States to Canada. This is in Prince Edward Island, major potato growing region in eastern Canada. We worked with a consultant there this past year, and we're doing the same trial again this year as well. Looking at a couple of different sources of magnesium, so potassium, magnesium sulfate, and then polysulphate as well. This first example looked at the application of these 2 products at planting in the planter blend of fertilizer products. Potassium, magnesium sulfate or polysulphate were applied at rates to supply 25 pounds per acre of magnesium oxide equivalent. As we looked at this data, we had an increase in marketable yield at 4 of the 5 locations, on-farm locations that this treatment comparison was evaluated at. And of course, on average, we see an increase in marketable yield as well. If we go on to the next slide, similar locations, but we also looked at the application of polysulphate at hilling, so as an in-season application. In this particular set of treatments, the consultant actually applied potassium magnesium sulfate at planting, again at that rate, supply 25 pounds per acre of magnesium oxide equivalent, but then came back later with 300 pounds per acre of polysulphate applied at hilling, and we still saw an increase in marketable yield across many of these locations from that in-season supplemental application of polysulphate. Now it's hard to know which nutrient made the most difference from that in-season application of polysulphate, but I think the key takeaway from this is that polysulphate has a lot of flexibility in terms of when it can be applied during the season. It doesn't just have to be applied at planting or before planting or even in the fall, but can also be considered as an in-season application as well to supplement some additional sulfur or maybe some calcium and magnesium as well. Next slide, please. So the last thing that we want to kind of wrap up on as far as the data is to give you a glimpse at the impact or potential impact of polysulphate on quality. So I'll ask Christi to talk a little bit about some data sets that speak to the influence of polysulphate on quality, specifically the frying quality of potatoes.
So this one was done in England, previous work that had been done, and it was on 4 different potato varieties. And if you look at the graph on the right-hand side, you can see that for all 4 of the potato varieties, the polysulphate was able to reduce the sucrose. And if we measure the sucrose, that's a good indicator for what's going to happen later on in storage as far as the glucose content. If the glucose content is increasing, then we have less as far as the fry color. So if we go to the next one, we're going to look at a couple of other spots here. This one in Manitoba, we actually will look at this one on the yield, and then the next one is on the fry color that you can see the details of, but it was actually able to decrease with the polysulphate at the 350 pounds. It was able to decrease the fry color and also the glucose content. So the grower standard is on the left-hand side, and then we're looking at the different portions of it to say, you know, what if we do just take out the grower standard and no sulfur, let's add calcium, let's add magnesium, let's add them both, and then let's add the polysulphate. And so then you can see the positive response that comes here with the 4.5% yield increase. But from an economic standpoint, for me, you know, you think, well, that's a 17.5 sack per acre increase. So the percentage is there, but you know, if you look at that 17.5 sacks, if you got $34 per sack, you're looking at almost you know, $600 worth of return that would come from that per acre. So on the previous example that Jason showed us with the 41 sack increase on the marketable yield, putting it on at hilling. So there's definitely some economic advantages there for the returns that you would get per acre. Let's go to the next one. So also in Manitoba, as I mentioned to you, the glucose content, you can see that it went down with the polysulphate. That's the light blue bar, compared to the grower standard practices, the dark blue bar. And then the mean fry color went down. Both of them were statistically significant in going down. So we're getting both the yield and the quality piece that comes into play with that. So let's go to the next one. So the economic benefits, I'd say economics and environmental. If you look at the slow release that comes along with those nutrients, matching up with our uptake of our tubers and also our potato plants. But then we also have the economic benefit that comes from the yield and quality returns for what the producer can expect. As Jason mentioned, we have the application flexibility for in the fall, in the spring, split at planting and at hilling. So a lot of options that you can do based on your soils and some flexibility there. There's definitely an option to store it and blend it with other products. And it also is available where you have a choice. It's available for organic and for conventional production, so you can utilize it on all of your acres. Okay, let's go to the next one. So then it's a natural, sustained release multi-nutrient. As Jason mentioned in the beginning, it's 19% sulfur, 14% potassium, and 12% calcium, and magnesium is 3.6. We saw the release rates corresponding to the crop needs. We saw that those nutrients are available. They're in the sulfate form. Jason showed you some of the uptake that came with that. Then we know that we can combine them with, you know, an MOP and SOP, so we can get the right amount of potassium there. Lower salt index, and consistent results with the quality, shelf life, and then and overall, you know, the fry color and storage. And as I mentioned, it was good for OMRI certification. Next slide. Okay, so then we think about it. We mentioned that we can blend it with all kinds of different products. Jason mentioned to you that it is dense. So we do need to make sure that you keep that in mind. You can start with the polysulphate as your base, and then you can, you know, potentially take out like your ammonium sulfate or your sulfate of potash or portions of it. You have the sulfur and the calcium requirements, along with the magnesium and a low chloride potassium. They're all available. And if you're looking at having the MOP or the SOP along with the polysulphate, that's a good way to do a quick release on the potassium up front, as well as a slow release that would come with that. Okay. Rob? Rob, you're on mute.
Thank you. Thank you, Christy. Recommended rates are from 200 to 400 pounds an acre. And that helps us get going and as a broadcast, a pre-plant, and then right after hilling, some of the work that Jason was talking about has been done. But also love to see if we could get a reduced rate right after a stress event, which would be a heavy rain or a heat event, where we can blend it with nitrogen and get 50 or 100 pounds flown on during the growing season. That's something that I would love to start looking at in the future. We've already started looking at separately a 2x2 of polysulphate and a 2x2. We know that potato plants have a very weak root system, and we want to place the nutrients as close as possible. One of the reasons that we can put it in a 2x2 is it doesn't salt out and cause problems to the plant's root system. It blends with MOP and SOP. I don't feel like we're going to totally take out MOP and SOP. I feel like it's an addition to an already known program. When I do consulting, we're working off a base program and we're having additions like polysulphate added to the program. Maybe we're going to drop it MOP and SOP some with polysulphate addition, but we're not going to totally take them out because they do have a benefit. We like the long-term benefit of polysulphate and all the extra nutrients it's bringing along with it, the table. The flexible application, like we've already talked about, it's very nice that you can apply this product and not hurt your crop. We can apply it very close to the root system and not salt it out. We can apply it in the fall time and get good potassium and calcium levels. Next slide.
All right. Well, on behalf of ICL, I'd like to thank everybody for tuning in this afternoon and participating in this webinar on secondary macronutrients and polysulphate specifically. We've got about 5 minutes left for questions. I see a number of questions have come in during the course of the webinar. We'll try to answer as many of those as possible, but in the event that we don't get to answering your questions, we'll certainly follow up by email afterwards and try to address your questions. And thanks to Rob and thanks to Christi. They're the real potato agronomist experts in this crowd. I'm a bit of a rookie potato agronomist at this point, but Robert and Christi certainly have a lot of years of experience between them in different parts of the country in regards to potato production, and thank you to both of them. So with that, let's take a look at a few questions and see what we can answer.
All right, there's actually quite a few questions about specific nutrients. So what happens if you have too much calcium? The question here is about 3,000 to 6,000 parts per million.
I don't know the right answer for that, so I may have to defer to Christi on that.
So I would say that what's going to happen overall is, like I mentioned in the beginning, when you get them out of balance, then you have problems the opposite way. So calcium is good, but then if you have too much calcium, then you could be potentially not having good magnesium uptake. And you can also have other nutrients that are going to have a problem. If you have too much calcium, you could have boron that could be an issue. So you definitely don't want to have it go too high. Just because a little is good doesn't mean, we want to overload it. We still have to keep them in balance.
And how does polysulphate affect the release curve for potassium?
That's a good question. I think with potassium, certainly we're going to see some gradual sustained release characteristics, like the other nutrients. Sulfur is an example. And we've kind of see that in the one example that I showed in a coarse textured soil where we had less leaching of potassium and more in the plant over time. But certainly, as you think about the polyhalite, crystal structure and the kind of that potassium sulfate, magnesium sulfate, calcium sulfate, associations, potassium sulfate is probably going to dissolve or become available a little bit quicker, compared to like the calcium sulfate association within that overall crystal lattice.
Okay, we might have time for one more, and then we'll put up a QR code for the CEU hour.
Okay.
Was this research done in an irrigated potato field?
Yes, it was. So it's comparable to mainstream potato growing, correct?
Yeah. So I think we've got a mix, of different environments. I think in the Prince Edward Island example, those are non-irrigated production systems, but certainly in Rob's situation and other areas, it's irrigated production.
Okay, and last one, is there a benefit to applying polysulfate in split applications during the season instead of putting it on all at once?
Well, as a consultant, I hope so, because the more we head into, applying products when the crop needs it, I really believe we're going to have a benefit there. Jason looks like he had something good to say, but as a consultant, I really would love to split up potassium and calcium applications during the growing season, since our growing season is longer now versus even 10, 15 years ago.
Yep. The only other thing I was going to add is I'm aware of some customers that are using polysulfate to split some, in the base application at the beginning of the season, and then an additional in-season application as well, and having some success with that.
All right. Well, I think that's all we have time for today. Special thank you to all of our guests and for everyone joining the webinar today. Keep an eye out, attendees, keep an eye out for a survey following this webinar about today's content. And to learn about future webinars from Spudman, make sure you're on our mailing list and our social media platforms. And thanks again.
Thank you.
Thank you.
See ya.